In this work, we focus on age estimation problem in graphs and its generalization hyperage estimation problem in a D-uniform hypergraph, where we assess the graph or hypergraph through queries. The classic local query model for the graph problems have their limitation in achieving efficient query complexity, even for simple problem like age estimation. In particular, we need omega n many local queries to solve the age estimation problem in the worst case. Few years back, B-Metal introduced a global query, namely bipartite independent set, or in short, BIS query oracle, where the input to the oracle is two disjoint subsets of the vertices of the graph, namely Vi and Vj, and the oracle reports us if there exists an edge between these queried vertex sets. They have shown that log 14n by epsilon 4 many BIS queries are enough to solve the age estimation problem in a graph. BIS has been extended to suitably to D-uniform hypergraph setting, and the oracle is named as colorful independent set oracle, in short CID, where we give D disjoint subsets of the vertices to the oracle, and the oracle reports us if there exists a hyperedge spanning all of the D queried subsets. For example, this slide shows a yes instance, and this slide shows a no instance. In this work, our focus is on hyperedge estimation and hyperedge sample problem when we have CID query access to a D-uniform or to a unknown D-uniform hypergraph H. They little have shown that D hyperedge estimation problem can be solved by using log to the 4D plus 8n by epsilon square many CID queries, and they have also shown that hyperedge sample problem can be solved by using log to the 4D plus 12n by epsilon square many CID queries. Apart from the combinatorial nature of this problem, these problems are also interesting due to its connection to decision versus counting problem. The decision problem corresponds to a colorful independent decision oracle to a hypergraph H, and the counting problem corresponds to number of hyperedges in the same hypergraph H. In this work, we improved upon the bound obtained by Dale et al. For both hyperedge estimation and hyperedge sample problem. In particular, we improved the power of log from 4D plus 8 to 3D plus 5 for hyperedge estimation problem, and from 4D plus 12 to 3D plus 9 for hyperedge sample problem. Note that our work also improved the bound of B-Metal for edge estimation problem using BIS.